We're now ready to explore the third and final part of our Java object-oriented BardWords case study. In this part of the lesson, we'll walk through the entire BardWords case study implementation from start to finish, with particular emphasis on parts of the implementation we didn't cover in the earlier two parts of this lesson. As usual, you can find the source code for this case study in the BardWords project in the CS folder in my Modern Java GitHub repository. Here we are in the BardWords project, and let's take a look at the bardwords.java file. This file contains the entry point for the case study that shows how Java's break iterator, regular expression methods, and other object-oriented features can be used to search the complete works of Shakespeare for given words and phrases. We'll start by taking a look at the BardWords class fields. As you can see, there's a field called Shakespeare data file, which contains the name of the file storing the complete works of William Shakespeare, which appears in the resources folder. If we go over here to the resources folder and click on the complete works of Shakespeare, you can see that it's got all the works of Shakespeare, and each work is separated by an @ sign. And if we click on that, we can go through and see all the different works. Shortly, we'll show how those @ signs are used in the getInput method from the testDataFactory class that reads this file and then creates a list of strings, one string per work of Shakespeare. There's a second field in this file as well, which is called sphrases. As you can see, sphrases is a list of simple entries, and simple entry is a class that's defined as part of the map collection. And as you can see here, it's simply an entry that maintains a key and value pair. We use the simple entry class as a way to keep track of a word to search for in the works of Shakespeare, as well as a regular expression to apply on any work that contains that word at least once. Let's now walk through the mPhraseList method that initializes the sphrases field. As you can see, this simply returns a list of simple entry objects that contain the word to search for and the regular expression to compile. We could have read this information from a file, but we chose to make it a simple list, and all we're doing is creating a new simple entry with the word Lord to search for, and then this is the regular expression that we're going to compile, which matches any phrases containing the word Lord, followed by either true or false. Note the use of the Java double braces initialization syntax, where we initialize the array list via a call to its add method without having to do anything separate other than create that particular instance. It's now time to turn our attention to the main entry point into this program. As you can see, this main method starts by creating a list of string objects that contain the complete works of Shakespeare, one work per string. And to do this, we call the testDataFactory getInput method, passing in the name of the file to read, as well as the symbol to use to split the file into works. Here's the implementation of the getInput method. As you can see, this method takes in the file name and the splitter, and the first thing it does is it uses the file name to get a path name, which essentially goes and looks up this complete works of Shakespeare.txt file in the resources folder. We convert that to a URI. We then open up that file, read all of its bytes, and store it into a string. Then we take the splitter, which was passed in, which is the @ sign. We compile that into a regular expression. We then use this regular expression to split the file into an array of string objects, and then convert this array into a list using the arrays @listFactory method. At this point, we take the split strings and we use the removeIf method on the string class to remove any string objects that are empty from the list. And finally, we return the list of non-empty string objects as the return value from the getInput method and store it back here into the BardWorks variable. At this point, we use the Java for-each loop to process the list of phrases to see where they occur in the complete works of Shakespeare. And to do this, we call the process BardWorks method, passing in the BardWorks list, as well as the word to search for, which is the first key portion of this simple entry, followed by the regular expression to compile, which is the value portion of this simple entry. Let's take a quick look at the process BardWorks method. We've looked at this before, so I won't dwell on it. Process BardWorks takes the list of BardWorks, the word we're looking for, and the regular expression to compile. It creates a new array list called BardWorks matching word, which is a list of Shakespeare works that contain the word parameter. And then once again, we use the for each loop to loop through each work in the BardWorks list. We call the findMatch method each time through this loop. And if the word appears in work, in other words, if findMatch returns true, then we're going to add that work to the BardWorks matching word list. Here's what the find match method looks like. As you can see here, this uses the break iterator that we've talked about before in order to break the works of Shakespeare into words using the UK locale, which we do, of course, because William Shakespeare was from England. As you can see, we call the get word instance factor method on break iterator, passing in the UK locale. That gets us back an iterator. We then associate the work with that iterator, and then we use a good old-fashioned Java for loop to iterate through all the text in the work. We start by getting the first and second word boundary from the iterator by calling the first and next methods on iterator, giving us the indices of the previous and current elements, respectively. We keep iterating until the break iterator is done. You can see we do that by checking to see if current is not equal to done, and when it's equal to done, we drop out. And then after the loop body executes, which we'll take a look at in a moment, then we're going to update the current boundary with the next word by calling the next method on the iterator. Looking inside the loop body itself, we call the substring method on the work string with the previous and current indices to get the word between the previous and current boundaries. And then we check to see if this word is indeed a word and whether it contains search word. And to do this, we check to see whether the first character in the word is a letter or a digit. And if it is, we then check to see whether the lowercase version of the word is equal to the search word, which was lowercased from the start. If that entire condition evaluates to true, we then return true from this method, bailing out of the loop. Otherwise, we make the current boundary the previous boundary and then loop back around again, after first updating current to be the next boundary found by the iterator's next method. Once this loop finishes, once current equals to break iterator done, then we're going to return false if there's no match that's occurred earlier by this check within the loop body. Now that we've walked through the find match method, let's wrap up our analysis of process BARD work. The next thing we do is we compile the regular expression to perform case-insensitive matches, which means that a word like Lord with a capital first letter, all lowercase letters, or all capital letters will all match this particular pattern. We compile the expression by calling the compile method on the pattern class, passing in the regular expression, as well as the case-insensitive flag. Then finally, we call the show regex matches method, which will show the portions of the works of Shakespeare that match the pattern. As we just discussed, this method takes a list of BARD works that match the word, and it also takes a pattern containing the regular expression to compile and use to match. The first thing this method does is print the regular expression pattern that we're searching for, simply to help explain the output. And next we use a Java for each loop to process each work in this list of BARD works that match the word. For each work that match, we then use a nested for each loop to iterate through each match in the work. And the way we do that is we use the work and we associate it with a pattern matcher. We then take that pattern matcher and call its find method. Find checks to see if there's a match, and if there is a match with the regular expression, it returns true, in which case we go ahead and execute the loop body. The loop body starts out by printing the title of the work. We'll see how that works in just a moment. And then it goes ahead and calls the group method on the matcher, which will print the input subsequence that was matched by the previous match that was performed by the find method up here. Note how we also print out the starting location where the match occurred. You'll see that when we print the output when we run the program here in just a moment. But before we run the program, let's take a quick look at the getFirstLine method. This uses a regular expression pattern matcher to match the first line of multi-line input, thereby being able to extract the title from a work of Shakespeare. In particular, if you look at the contents of the complete works of Shakespeare file, you'll see that each of these works of Shakespeare begin with the first line containing the title. To extract only the title, we pass in a regular expression with this format, we compile it, and then we associate that regular expression with the input string to create a matcher. At this point, we call the find method on the matcher, which will find and return the first line in the string if there is one. Assuming find returns true, the group method is then called on the matcher, which returns a string containing the first line. If for some strange reason there is no match, then we return an empty string. So that's the walkthrough of the implementation of the getFirstLine method. So now that we've walked through all the source code for the BardWords case study, let's go ahead and run the program to see what its output is. To do this, we go and click on the green button to run the BardWords program towards the top of the IntelliJ IDE. At this point, the program compiles and then it runs, and here's the output it provides. You can see here the first thing it does is it prints the regular expression pattern and the word that we're searching for, which of course is Lord followed by anything, followed by either true or false on a line. And if you look down here, you can see some of the output output that comes from processing the complete works of William Shakespeare with that regular expression. For example, you can see in the tragedy of Hamlet, Prince of Denmark, it finds the "Lord, 'tis true" phrase, which occurs at this character offset in the play. Down here, you can see the tragedy of Julius Caesar. We see "Lord, are false," which also appears at a particular offset. And there's many more examples here as well. We'll take a look at one more example from The Tempest, which says, "Lord, you play me false." So that shows the output that occurs when we run the regular expression with the BardWords program on the complete works of Shakespeare. Hopefully you've enjoyed this example, which demonstrated the use of the Java break iterator, Java regular expressions, as well as a number of other Java object-oriented features, such as classes, for each loops, and so on.